The article of the day is The Modern Algorithmic Toolbox Consistent Hashing. The original motivation for consistent hashing in 1997 was web caching. You're familiar with the concept and benefits of caching in the context of the web. Imagine a browser requesting a URL like Amazon.com. Of course, one could request the page from the appropriate web server, but if the page is being requested over and over again, it's wasteful to repeatedly download it from the server. An obvious idea is to use a web cache, which stores a local copy of the recently visited pages. When a URL is requested, one can first check the local cache for the page. If the page is in cache, one can send it directly to the browser, no need to contact the original server. If the page is not in the cache, then the page is downloaded from a suitable server as before, and the result is both sent to the browser and also stored in the local cache for future reuse. Caching is good. The most obvious benefit is that the end user experience a much faster response time. Caches also improve the internet as a whole. Fewer requests to far away servers means less network traffic, less congestion in the queues at network switches and web servers, fewer drop packets, etc. Formally, we want a mapping from URLs to caches. The first thought of a well-trained computer scientist might be to use a hash function for this purpose. Recall that a hash function maps elements of a universe U like URLs to buckets such as 32-bit values. A good hash function satisfies two properties. It is easy to remember and evaluate. Ideally, the computing the function involves just a few arithmetic operations and maybe a mod operation. For all practical purposes, H behaves like a totally random function spreading data out evenly and without noticeable correlation across the possible buckets. Our criticism of the solution of mapping URLs to caches motivates the goal of consistent hashing. We want hash table type functionality. We can store stuff and retrieve it later with the additional property that almost all objects stay assigned to the same cache even as the number of n caches changes. The key idea is in addition to hashing the names of all the objects X like before, we also hash the names of all the server S. The object and server names need to be hashed to the same range, such as the 32-bit value. Here is some interesting history of consistent hashing. In 1997, the implementation of consistent hashing, as detailed out in this article, first appeared in a research paper in STOC, that is Symposium on the Theory of Computing. This is one of the main conferences in theoretical computer science. Ironically, the paper had previously been rejected from a theoretical computer science conference because at least one reviewer felt that it had no hope of being practical. 1998, Akamai is founded. March 31st, 1999, a trailer for Star Wars The Phantom Menace is released online with Apple the exclusive official distributor. Apple.com goes down almost immediately due to the overwhelming number of download requests. For a good part of the day, the only place to watch the trailer is via Akamai's web caches. This put Akamai on the map. April 1st, 1999, Steve Jobs, having noticed Akamai's performance the day before, calls Akamai's president Paul Sagan to talk. Sagan hangs up on Jobs, thinking it's an April Fool's prank by one of the co-founders. September 11, 2001. Tragically, co-founder Denny Levin is killed aboard the first airplane that crashes into the World Trade Center. 2001. Consistent hashing is repurposed to address technical challenges that arise in peer-to-peer networks. A key issue in P2P networks is how to keep track of where to look for a file such as MP3. This functionality is often called the distributed hash table. DSTs were a very hot topic of research in the early years of 21st century. First generation P2P networks like Napster solve this problem by having a centralized server keep track of where everything is. Such a network has a simple single point of failure and thus is easy to shut down. Second generation P2P networks like Nutella use broadcasting protocols so that everyone could keep track of where everything is. This is an expensive solution that does not scale well with the number of nodes. Third generation P2P networks like CORD use consistent hashing to keep track of what's where. The key challenge is to implement the successor operation discussed in the article, even though nobody is keeping track of full set of servers. The high-level idea in which has been copied and refined in several subsequent P2P networks is that each machine should be responsible for keeping track of a small number of other machines in the network. An object search is then sent to the appropriate machine using a clever routing protocol. Consistent hashing remains in use in modern P2P networks, including for some of the features of BitTorrent protocol. 2006, Amazon implements its internal Dynamo system using consistent hashing. The goal of the system is to store tons of stuff using commodity hardware while maintaining a very fast response time. as much data as possible is stored in main memory, and consistent hashing is used to keep track of what's where. The idea is now widely copied in modern lightweight alternatives to traditional databases. Such alternatives generally support few operations and relax traditional consistency requirements in exchange for speed. As you can imagine, this is a big win for lots of modern internet companies.